Okay, so let's move into the biosynthesis of chorismic acid. So I just wanted to know that I am explaining this mechanism based on the anion forms. Like you can take it to the neutral compounds also. So basically, what you have to do is, in this case, this is an anion form. You just add the hydrogen to this carboxyl ion. It's basically the neutral compound. If you're wondering where this molecule came from, right? Dihydroquinone. We have synthesized this molecule in our previous video, so I'm gonna put my link for that particular video on up of your screen. You can go to that video and check out how we can synthesize this particular molecule. Let's move into our mechanism. So first step, what's gonna happen is a dehydration. You know, there's a hydrogen on this particular place. This OH and this hydrogen both will eliminate as water to form a double bond between these two carbons. And then we are going to use NADPH. I hope you know what's the function of this NADPH is. We can use NADP. We basically, like, there are two compounds which can donate hydrogen atoms to our particular molecules in biological systems. NADPH is one molecule and other one is the NADH. So I hope you know about these two functions. Like if you are not aware of these two molecules and these two enzymes and its functions, just don't worry. You just need to in this case, like for this particular biosynthesis method, just know that these NADPH can donate its hydrogen to our carbonyl atoms, carbonyl oxygen. So what happens is this carbonyl group will be converted into hydroxyl group. That's what we are going to see at this particular reaction step. And then in the next step, we can see we are adding these are all based on the biological system. So these all reactions are enzyme driven reactions. We cannot perform this reaction on a in a lab, like in this mechanism, right? Like we cannot do this exact mechanism in a lab, so it's really hard because these all are enzyme driven reactions. So ATP, right? ATP will donate its one phosphate group to our original molecule. So here you can see the phosphate group will be added to here, right? So instead of hydrogen, this phosphate group will be added, and this is a very important step, right? So here what's happened? So this is a double bond, like there's a CH2 over here. So what happens is there is these two valence 2 electrons. This one electron will go and attack to here. Due to this attack, this double bond, one of this double bond will go and find a proton to connect. Right? So you may now wonder, like, this is not a carbonyl group, right? This is not a carbonyl group. This is a CH2 group. So how can we attack this nucleophile into a carbonyl center? Like, as I was telling, these are enzyme driven reactions, right? So these are enzyme driven reaction. You can see EPSP synthase. This is an enzyme which drive this particular reaction step. So that's how this is possible. With enzymes, these reactions are possible. You need to memorize these kind of special points. So what we are gonna obtain is, I'm going to draw the intermediate structure for here. So let me draw it. Here we have our original molecule, CO2 minus, and here we have a double bond. Here we have a oxygen and phosphate group. I hope you know what the P means, right? This P means not the phosphorus, it's phosphate, right? It's a phosphate group. And here we have a OH. Now here you can see the oxygen. This is the oxygen from here. This is the oxygen, right? And now this oxygen have attacked into this carbonyl group. So here we have a carbon. This carbon is on here, and here you have CH2. Now this carbon, right, you can see it has attacked to another proton. So here you have another hydrogen, and on downwards you have like OP group, and this part you have CO2 minus. The next step, what happens is this hydrogen will be removed again, right? And due to this electron transfer, this bond will be broken. So you can see like hydrogen and OP group both are leaving when it's forming this particular compound. Now you can see like you have this particular compound. So what happens is HOP group will be removed when this happens. This is the mechanism. So I hope you get the idea. I hope you got the idea about this particular reaction, right? This particular step. Now we have here, now we have here. And in the next step, what happens is a phosphate group, right? A phosphate group, not a phosphate group. Right? Let me erase that. Oh, sorry. Yeah, I just saved it. Let me cut it out. Okay, it's just not a phosphate group. It's a HOP group. Hydrogen, oxygen, and phosphate group. So what happens? This bond will be broken with alongside this hydrogen. So this double bond will be shifted to its adjacent carbon. So here we have our final product, final molecule. This is the chorismic. Right? Otherwise, like if you want the original neutral like chorismic acid, you just put 2 hydrogens for this, right? So then you can obtain the chorismic acid. So this is basically the biosynthesis pathway for the chorismic acid, or otherwise the anion form chorismate. So I hope you got the idea. Like these are simple mechanisms. These are simple mechanisms which are derivatives. Like these are the derivatives of our shikimic pathway. So in our next video, we may continue from this chorismic acid. I hope you know what we are talking about now.